Hello and welcome to the Red Hat Summit version 2020. Today in this session, we're going to talk about Red Hat OpenShift and Red Hat OpenShift Virtualization. As a quick introduction, I'm your speaker. My name is Rob Young. I'm a senior manager with product management within the Cloud Platforms business unit at Red Hat. Much of my focus over the course of the last 20 years has been around technical product management focused on open source, specifically around the open source development model. And I've also got experience across engineering, application development in the corporate community and enterprise software spaces as well. Joining me in a virtual way, our demo creator and presenter is Andrew Sullivan, also known as Sully. Andrew is an industry-recognized guru when it comes to things like system administration, architecture, automation. He's also very well-versed in storage and virtualization. Andrew is in our technical marketing division within Red Hat. Technology built around Kubernetes, native infrastructure, and containerized applications and workflows. As part of that, we'll be building on some of the announcements you've heard around OpenShift and OpenShift Virtualization as part of some early summit information you may have heard or consumed. As part of that, we'll also talk about the future of virtualization from Red Hat as part of our strategy and our plan and just overall operational and developer unification and convergence on a single platform. And then we'll see this at work via a live demonstration. And then finally, we'll wrap up with how you can learn more about what we've talked about on today's session. So to get started, a lot of what we're talking about today around Kubernetes native infrastructure and applications that run on these application infrastructures are really about the value that we add as engineering and technical resources within not only our own organizations, but also externally to our customers and to society in general. So a lot of the way that we are delivering our applications have to be agile. We have to be very nimble in how we deliver solutions to the market. And these new paradigms that are built around cloud-native applications, machine learning, analytics, Internet of Things and devices, and the innovation culture that empowers all these things is powered more and more by containers, Kubernetes, and hybrid cloud environments. And we feel at Red Hat that OpenShift is the best version of Kubernetes available and the best platform to deliver these modernized and cloud-native applications that solve key problems around agility and the ability to add value as application developers and technical folks within our own organizations and outside. So if you look at how we are doing that with our customers now, OpenShift is basically a commercial version of Kubernetes, complete from end to end, Kubernetes native infrastructure that many customers and industries are using to modernize their applications and to deliver a user experience that enables customers to consume products, to consume healthcare, to have a secure relationship with their bank, different things like that. But the other thing that we've seen is the transformational nature of not only how these applications impact customers, but also how they're benefiting society as a whole. We talk to customers that we have, across the automotive industry as an example. Many tell us that their products and their average car contain 10 million lines of code. And these aren't only things that allow the car to be more, or the automobile to be more comfortable or that type of thing, knowing maintenance schedules are all that, but also to be more safe as well. So we can enable entire industries to not only provide better products, but also to make sure that safety, security, and things like that are built in. Another great example in that is ripped from today's headlines are things that we can enable with OpenShift and Kubernetes around things like big data and analytics. We can connect data points for things like diseases and cure rates and preventable things around infections that we could never do in the past with traditional ways of delivering applications. So OpenShift and Kubernetes allows for rapid and agile development of solutions, but they're more timely, so developers can deliver new variables or new schemas or new data points within an application within hours, where before they would have to follow a watershed delivery that may take weeks or months, and in some cases even years. So OpenShift customers, we have about 1,700 right now across the different verticals that you see here, but many of the logos that you see here are using us to make sure that not only can they provide a user experience that is much more agile, but it also allows these applications to conform and to evolve to the way that we're living as a society today. As we see more customers adopting Kubernetes native infrastructure and containers, we also see two emerging trends. Currently in the market and in this space, about 90% of workloads continue to run on virtual machines on dedicated hosts running within the data center. We also have a trend where containers are taking much more of a role within the data center. About 10% of workloads are running on containers. And these two technologies running within a data center will continue to evolve and mature, but the ratio is going to begin balancing out to more of an 80-20 split, a 70-30 split, you name it. But as that happens, the model of maintaining two environments, one for traditional workloads, one for containers, becomes less sustainable, and we have to meet the demand for customers that are moving more to more of a modernization strategy to allow those traditional workloads to also be compatible on that platform or the platforms that they choose. If we look at Red Hat OpenShift and OpenShift Virtualization, we solve this problem by allowing traditional workloads running on VMs to run side by side with containers on top of the OpenShift platform and on top of the Kubernetes native infrastructure that it provides. So what this does, the technology that we have built into OpenShift Virtualization runs on top of OpenShift, and this allows for virtual machines to be ported over or to be converted over to a containerized way of managing those workloads under Kubernetes KNI infrastructure. And what this does is it allows customers to modernize existing workloads without having to re-architect the underlying applications. And this allows for acceleration of application delivery from a single platform. It also allows for mixed applications running traditional workloads and containers side by side, but it also allows the existing applications to be modernized, as well as the new containerized applications for net new development. And what this allows is for those virtual machines and the applications running on them to either migrate and be decomposed into containerized microservices, or they can continue to be maintained as virtual machines and to be managed as if they were Kubernetes native objects. And the way that we do this is the OpenShift platform allows for virtual machines to be pulled in and be managed under OpenShift Virtualization, and for containers to be managed as they are today using the infrastructure that OpenShift provides for Kubernetes managed objects. If we unpack this a little bit, we look at how the platform is organized and structured and the workloads that can now be deployed via OpenShift virtualization. So with one platform for on-premise data center, edge, or hybrid cloud environments, we have our management layer for Kubernetes. This is the container and DevOps platform that we provide via OpenShift. But now we can run traditional workloads, running traditional virtual machines. We have cloud-native applications that can be deployed via serverless across hybrid cloud, so on-premise, infrastructure agnostic, as far as the hybrid cloud, the bare metal, or virtualized control plane. And then we have use cases around AI and ML and other acceleration functions that empower these things. So if we drill into each of these, the VMs on OpenShift virtualization, the traditional workloads, these are things like databases, mail servers, exchange servers, middleware, application servers, the things that are, at some point will be decomposed into microservices, but, at today's pace will likely remain in virtual machines, maybe forever. So we now service those on top of Red Hat OpenStack or OpenShift. And we also have containers and serverless on-cloud virtual and physical infrastructure options for deploying Red Hat OpenShift as well. So developers can now develop and deploy their applications without worrying about where they will be serviced. Traditionally, this has been a function and a feature of public cloud providers. This is provided and supported within OpenShift now. OpenShift itself can be deployed within a public cloud. It can be deployed on Red Hat virtualization or on OpenStack or other hypervisor-based solutions. But we can also deploy OpenShift on bare metal as well, so that customers have ultimate flexibility on where it will be run, where it will run and operationally be maintained. And then finally, we have use cases that allow not only developers and operators to benefit from all of the benefits of OpenShift, but we also provide advanced capabilities for containers running on physical servers. So things like GPU and video acceleration, anything that is programmable around FPGA for field programmable gate arrays, TPUs for the tensor processing unit framework that has been introduced by Google and some other platforms. We now provide those capabilities for those use cases and deployments of OpenShift. So these are all very focused, but they also provide one platform where traditionally multiple platforms would have been needed in the past. So if we also take it one step further to another vertical, if we look at the things that are required from the telco industry and others that require very high bandwidth and very high low latency experience for a high number of users, simultaneous users, concurrent applications, that type of thing. We also provide things like SRILV and the CNF functions that each of these use cases will require. So if we look at OpenShift and the value propositions that we provide today as part of the OpenShift platform, developers, operators can now start bringing virtual machines into OpenShift now. This has been available since OpenShift 3.11. It's available now in the latest version of OpenShift, so this is available today. We now deliver mixed applications on one platform, so developers can now mix traditional virtual machines and the requirements that come along with the applications that are running on them within one platform, that being OpenShift, running next to containers. for more modernized applications, so they can be commingled. And then finally, we allow the choice, not to take the all-at-once jump for application modernization, but applications that will take time to decompose into microservices can now be moved over to OpenShift and be managed as if they were K&I native objects, side by side next to those that are containerized already and modernized. So when we start asking the question where the benefits lies, we start with operations. Traditionally, this has been the most complex, the most, anything that comes through a development requirement, application requirement goes through the operational function within any organization. And what we provide now with OpenShift is we have a consistent management of virtual machines and new modern applications running on containers. This simplifies the dev operations for an organization, but it also puts the developer and the operational staff on the same page. They see the same things, they have the same type of viewpoint into the environment. So the context shifting is greatly simplified. We also allow operationally there to be a cost savings, so that once a standardization is made, all the advantages that are made for density, server density, the scale of Kubernetes, the way that the agility that can be made both operationally from a development standpoint equates to cost savings that can be put into innovation and business strategies as opposed to operational inefficiencies. We also allow for the repurposing of hardware investments or OpEx investments. So as virtual machines and virtual environments are turned off, that hardware, the networking resources, the storage resources can then be dedicated to more OpenShift clusters. We also allow operational staff to be more proactive in their skills development around where the market is headed with Kubernetes and application and operational modernization. So the incentive is here as well. And then finally, we allow for the modernization of operational models. So things like SRE, things like CI/CD, other things can be built in and around what OpenShift provides. So what's in it for developers? Well, OpenShift Virtualization now puts developers in complete control over application lifecycles. It allows them to mix traditional VMs and workloads and the applications running on them with new modern containerized workloads. It also allows for agility. So those workloads can now be commingled and with containers, but they can also be managed as if they were K&I objects. So they can be portable. VMs can be stood up and easily managed as if they were containers. So they can be stood up and burned down quite quickly as part of application and container paradigm. We also allow for the VMs and workloads to take advantage of the integration and the simplification of OpenShift running as part of the DevOps workflow. And then finally, the refactoring of VMs can be done, on a schedule that more matches a reasonable life cycle. So they can immediately be converted over containers, or this can happen over time, or maybe never at all. But at some point, an application will be decomposed into microservices, and what we allow is for this to happen at the developer and organizational's pace, as opposed to it being an all-at-once type of transition. And then finally, Windows applications can easily be ported over to OpenShift. If they're running on virtual machines today, those guests can be moved over to OpenShift, and then when the Windows container option is available from Kubernetes, they can be decomposed and ported over to that option. But we provide an immediate option as a Windows client running applications on OpenShift virtualization today. Now, if you're wondering how I can get my virtual machines from where they're running today into OpenShift and OpenShift virtualization, we do provide a import wizard within OpenShift itself. This supports VMware, it supports Red Hat virtualization and Red Hat OpenStack platform. So single VMs can be brought over via the import wizard. This is very straightforward. It walks you through every single step of the way. And the cool thing about this is we allow this for single VMs, but you can build a template that can easily be replicated across OpenShift virtualization. Now, we also provide a migration tool. It's currently part of our cloud platforms, or our CloudForms platform that will allow for this to happen in bulk and in mass. That is being ported over to OpenShift, so it will be available as part of the OpenShift platform moving forward. But we have that option available today. So if you have multiple VMs, they can be brought over in mass as well. So what's in this for VMware customers? I mentioned VMware a little bit earlier. What this does is, what OpenShift and OpenShift virtualization does is it allows for the complete application development stack to happen, one in a KNI native infrastructure, but also from a single platform and a single solution. And what this does is it allows for, the overhead of running VMware proprietary stack, if you will, to be consolidated and to the cost savings associated with that to be enjoyed, to be invested in other areas. It also cuts the risk of being locked into a single provider for a public cloud provider or even a proprietary vendor. So with OpenShift, again, we are independent from infrastructure, so OpenShift can be deployed on bare metal, on-premise virtualization, public cloud, but what this does is provides choice. It allows independence and portability of applications as well. And then finally, VMware and others are proprietary solutions with some open source components. OpenShift and OpenShift virtualization are pure open source. We benefit from the open source development model and the innovation that comes along with that. We also feel that OpenShift and Kubernetes are the direction of the future. They are built on containers, containerized workloads, and VMs running on containers. And we feel that this greatly accelerates not only application modernization, but also the ability for operators and developers to deliver on the promise and the agility that they have to their end users as well. So this is, Red Hat is a leader in open source. We have been for 25 years, even more with Red Hat Enterprise Linux. Kubernetes and OpenShift is just an extension of that leadership in the market where developers and applications are going today and tomorrow. So now let's see it in action.
This video will show the process of creating a Windows Server 2019 virtual machine using OpenShift virtualization. We will start with our OpenShift cluster. This cluster is relatively small with a few other containerized and virtualized workloads running. Here we see a containerized guestbook application, a quaint relic of a bygone time using Redis and PHP. Moving to the NCC 1701A namespace, we see there are some other virtual machines already running. The pods we see here represent the libvirt, QEMU, and other container-based technologies being used to instantiate and manage our virtual machines. Moving to the virtual machines view, we get a more concise perspective of the virtual machines. If we were to look at the options for these by clicking the three dots on the right side, currently highlighted, we would see operations like start, stop, and delete for the virtual machines, standard management capabilities. Because OpenShift virtualization is Kubernetes-based, we have the option of defining the virtual machines using YAML. However, to illustrate the process, we will use the wizard for our Windows Server virtual machine. The first question asked by the wizard is the source of the virtual machine. The options here are to create a VM with no disk for PXE booting, use a URL to import a disk to a new volume, use a container image for the disk, or attach a new or existing PVC to the VM. For this demonstration, I'm going to select disk. We will do this to use a pre-existing PVC, which has been pre-staged with the Windows operating system in order to save time. You can see a significantly accelerated version of importing the 40 GB disk on the screen now. I'll pause briefly to highlight that this disk is being imported from a KVM-ready Windows image, which was created for OpenStack. The process is straightforward, relying on the standard Kubernetes persistent storage paradigm of persistent volume claims to request storage, which is then met by a storage class. With the source defined, we tell OpenShift Virtualization which operating system we're using. I'm choosing to use a predefined virtual machine size of medium, which represents 2 vCPUs and 8 GB of RAM. This is a server workload, so we want to be sure to set the profile correctly. And last, for the screen, we will set the host name. The next screen of the wizard will ask us what network we want to connect to. Here we will select the administrator-defined external network for VLAN 14, which uses Multis to create the resources on each of the OpenShift nodes and connect the pods to an external network. The final step is to attach the pre-allocated disk. As with any other Kubernetes pod needing persistence, the disk is defined as a PVC with a storage class associated for dynamic provisioning. For Linux-based operating systems, we have the option of providing cloud init configuration here. We won't use this with our Windows virtual machine, however. With the virtual machine defined and created, we're ready to turn it on. The details for a powered-off virtual machine are not terribly interesting, so we'll use the menu to power on the VM. After a few moments to create the virtual machine instance pod and allow Kubernetes to schedule it, we see the VM go from starting to running. At this point, we can use the built-in viewer to see the virtual machine console and wait for it to boot. After Windows has successfully booted, we can hand off to the security team for them to take ownership and deploy the application. Since this VM is connected directly to an external network, no Kubernetes service or OpenShift route needs to be defined to enable access. I hope this introduction to creating virtual machines with OpenShift Virtualization has provided a provocative peek into what's to come. Thank you for attending.
So as you can see from the demo, the integration with Red Hat OpenShift and Red Hat Virtualization is very seamless. The user experience should be very straightforward and easy to use. And again, Red Hat Virtualization is part of the Red Hat OpenShift platform today, so you can begin using it. And part of the advantage to introducing this now is we are also integrating it with our current virtualization product suite. So as an example, Red Hat Virtualization 4.4 now integrates with OpenShift Virtualization, and you can manage day 1 and day 2 VM lifecycle operations directly from the Rev Manager console. It is easy as adding an external provider. So again, it's very straightforward. It is wizard driven. If you have Red Hat Virtualization and Red Hat OpenShift running within the environment and they can see each other, you can begin using this functionality beginning with Red Hat Virtualization 4.4. Again, if you want to manage virtual machines running on OpenShift via OpenShift Virtualization, you can do so directly within the Rev console. This also allows you to start and stop, pause, migrate, and do other basic level functionality. Going forward, we will be working on adding the migration tooling for bulk migrations from Red Hat Virtualization directly to OpenShift and CNV. We are also adding our migration analytics product integration to this as well, so that not only will you be able to do migrations, but you will be able to do the analytics to identify the inventories of each and to proactively identify virtual machines and workloads that are candidate to move over to OpenShift and to OpenShift Virtualization. Many of you will have questions about the future of virtualization and our solutions from Red Hat. As you can see here, we have two current solutions for Red Hat virtualization. One is Red Hat virtualization itself. This is for traditional virtual machines running on dedicated hypervisor hosts. We also have Red Hat OpenStack platform for private cloud and NFE and telco use cases. These two products will continue on. We are providing them to current customers for long life use cases. Our focus here will be rock solid stability, performance, and scale. And we also provide them as landing spots for migrations from VMware. They will also, moving forward, provide customers with a path to OpenShift and OpenShift virtualization. This will not only provide them with the stability for the current use cases, but also with the things like integration with the tooling, the data migration or the migration analytics that will allow them to identify their workloads that are candidate to move to OpenShift virtualization. So integration with these products and with the OpenShift platform moving forward will be our focus. And then on the right side of this slide, this is our unified platform built on OpenShift for containers, virtual machines, and serverless applications. This will provide a unified experience for operational staff and developers for bare metal, virtual machines, private and public clouds, and edge deployments. And this is really, Red Hat's strategy for helping customers in their journey to application modernization with zero technical debt for migrations from VMware, from Red Hat Virtualization and Red Hat OpenStack. And this is our strategy and our investment roadmap for virtualization from Red Hat across all of the footprints that I mentioned. So how do you get OpenShift virtualization? Well, first of all, if you're an OpenShift customer, a container platform customer, or OpenShift Kubernetes engine customer, you have it now. It is in technical preview. We are working with our some high-touch beta customers through account team nominations right now. The planned GA fully supported GA date for this is in the second half of 2020 calendar year. If you want to learn more, you can reach out to your account team. They'll be happy to help you, on the nomination process for the high-touch beta. If you follow the Red Hat OpenShift blog, there will be blogs on Red Hat OpenShift virtualization from a general and a technical standpoint. And if you'd like to learn more about the technologies that we're using in the upstream community, KubeVirt is our upstream community for Red Hat OpenShift virtualization. It is an active community. If you'd like to learn more about it, you can follow this link. You can participate. You can become an active contributor. And if you do a search on container native virtualization as well, this is what we had previously called this technology, that you can find that as well. So with that concludes today's session. Thank you for your time and attention.